section, 1-6 relations, algebra 1. So we're going to actually really talk about relations, talk about graphs, and kind of talk about some terminology. I know that everybody knows the coordinate system or the coordinate plane. It's formed by the intersection of an x-axis and a y-axis. So that's our standard old school graph. Remember x and y. So an ordered pair is a set of numbers written as always x first, then y. Remember alphabetical. The x coordinate is how far horizontally you move, left and right. Positive means you go right, negative means you go left. Y coordinate is a vertical placement of a point. Positive means you go up, negative means you go down. All of that should be a repeat for you. Domain and range, I think you've heard of before. Domain is the set of the first numbers of the ordered pairs, or the x values. And surprisingly, the range is the set of all the second numbers of ordered pairs, aka the y values. You may or may not, however, have heard of independent and dependent variables. And I put them together this way on purpose. Whoops, scoot that down a teeny bit. The independent variable is the variable that determines the output. It's independent. You get to choose that value. If you think about when we were in the last section doing our replacement set, we take our x values and put them in, and then what we used for the x value determined what we got for the y value. So the dependent variable is the output or the value after using that independent variable. So in other words, the independent variable is what we put in for x, and the y depends on what we put in for x. So domain and independent go together, and the range and the dependent. So that's why I kind of put it in that little box down there. So a relation, this is actually super easy. It looks intimidating at first, but a relation is a set of ordered pairs. So I could give you 10 different ordered pairs, and we can represent them 4 different ways. We could keep them as ordered pairs, like 4, 5. We could turn them into a table. X, Y table, we put the values in there. We could put them on a graph. So we've got ourselves an x-axis and a y-axis, and we've got our relation on the graph. Or we could make a mapping. Mapping is probably the one thing that's new, where we have 2 bubbles. The first one's an x bubble, the second one's a y bubble, and then we have values going out from the x to the y. Kind of a graphic organizer for ordered pairs. So we're going to spend some time going between those 4 different ways to represent a relation. So for practice A, the directions tell you to express the relation with 4 ordered pairs as a table, a graph, and a mapping. Obviously, I already gave you the ordered pairs, so I don't really want you to rewrite those. So here's our 4 ordered pairs. If we're going to make a table, we're just going to make an x. So my first x value from my set of ordered pairs is 3, and the y value for 3 is 2. My second value is -1 for x, which goes with 4 for y. My next ordered pair is 0 with -3, and my last ordered pair is -3 that goes with a 4. We could make a graph so we can actually plot those points. So 3, 2, 3, 1, 2 lands over here in quadrant 1. My board's a little bit off. -1, 4. Whoops, I accidentally touched it. Let me try again. Lands somewhere around here. 0, -3, over 0, down 3. Remember, it's always horizontal first, vertical second. And -3, 4 lands right about here, sort of next to that one. Again, my board's off. Make sure your points are a little bit better. So there's the way to express that relation as a graph. That's all you have to do. Do not connect the points. Just leave them. And then the mapping. My first ordered pair, this is x, this is y, is 3 to 2. My next ordered pair is -1. We have to have those arrows to show that my -1 is my independent and the y depends on that. My next ordered pair is 0, -3. And my last ordered pair is -3, 4. Well, please notice, I already wrote the 4. I don't want to repeat values in my mapping. So I'm just going to put an arrow and reuse that 4. I don't get super picky about things being in order for the mapping. You could put them from smallest to biggest if you want, but I think that's perfectly fine. Now I want to determine the domain and the range. Which values are the domain again? And which values are the range? These ones I want you to put in a solution set or in set notation. So we're going to put those swirly brackets, and these ones should be in order. This is the only place I get picky. When you write out the domain and range, there is no good way to show what goes with what. In a table, a graph, a mapping, and ordered pairs, you always know what pairs up. In a domain and range, you just know what values they are. So my smallest value of my domain is -3, then -1, then 0, then 3. I found those by looking right here. I thought that was the easiest place. Over here would be an easy place as well. When I go to write in my values of my range from smallest to largest, my smallest value, how many values do I have in the range? The mapping kind of gave that away, right, when we reused that 4. So I've got -3, 2, 4. So put those guys in set notation in order. Otherwise, and we cannot determine what matches up with what. What are the ordered pairs? All right, so now let's think a little bit about graphs. Identify the independent and the dependent variable in each situation. So if we're thinking graph-wise, and usually when we have graphs for situation, x, y, remember x is the independent, y is the dependent. So in situation A, the cost of going to a movie has increased over the years. What would go on that x-axis? We have two things that we need to talk about. The cost of a movie and over the years, right? So what's going to be independent or across the bottom? Is the cost depending on the years or the years depending on the cost? So cost is depending on the years, right? So here would be the years, and here would be the cost. So what year it is depends, or what cost it is depends on what year. So year is independent, cost depends on the other. For situation B, as the temperature increases, the sales of winter coats decreases. So the two things I'm dealing with are the temperature and the sales of winter coats. What depends on what? Which one goes across the x-axis or is the independent variable? Temperature, right? And then the sales of coats. So the sales of coats depends on the temperature. So the sales is the dependent, the temperature is the independent. Usually it's things like time and temperature that go across the x-axis, just a little hint. And last but not least, let's talk about what these graphs are doing. Describe what's happening in each graph, be specific. So let's talk about driving to school. Letter B. We're going to do quite a few of these. Be specific. You can even make a situation. So notice my two variables, time across for independent and distance. So right here, we need to address this first part right here. So let's say we drive fast, because if we drive fast, we go further, right? Say we're driving fast down Marine City Highway, and then we have to stop because it flattens off. We're not getting any more distance during that time. Then stop for a bus. And then we maybe follow the bus. It's not going as fast. Do you see how I'm picking each part? This is the be specific part. And then we have to stop again right here. And then maybe the bus is turned left or something and we got away from it, so then we can just keep driving. Then keep driving. So there is our situation. Now you might not want to say you're going to school down Marine City Highway. You could say something else, but notice how I addressed each different piece of that graph, how it changed. If I were doing this one over here, I would talk about what's happening there, and then I would mention this part, and then I would say what happened there. So I want all the pieces of that graph. And notice I didn't actually say anything about time and distance specifically, but I try to always say include the label. Because we do need to address, we kind of do, you know, we drove fast, we stopped. But really should mention the labels as well. And we'll do some that the labels come in really specific. So lesson summary. Tell me the difference between domain and range. That should be short and sweet. Hopefully you know. And if I give you the situation in green, I want you to identify the dependent and independent variables. So the number of calories you burn increases as the number of minutes that you exercise increases. So calories increases as minutes increase. Which one is independent and which one is dependent? That's it for section 1-6. Bring your questions to class and we will talk next time.